Hey, what are you doing?
Oh, what's up, Josh? Not much, man. I'm just taking some samples from work. I'm a mechanical engineer, and so what my job is, I just take samples of airflow to see whether or not a jet will fly or not.
Sounds interesting. So, what's the difference between mechanical,
Yeah.
your engineering, and like electrical engineering?
Well, mechanical engineers focus on designing and developing what you would think of anything as a machine, and so the machines usually work on anything that produces power, and in a sense of a nuclear reactor, a jet engine, a car engine, um, and then it also works on heating and cooling, such as air conditioned systems and refrigerators.
So, that would differ from electrical engineering because mechanical engineering focuses on machines, and electrical engineering is fairly limited to electricity.
Yeah, of course, that's pretty much it.
So, my statistics teacher says statistics is in all the engineering disciplines, but that doesn't make a lot of sense to me. Where does statistics come in mechanical engineering?
For example, the 12 samples that we received today from work, I can take the average of those and I can develop a general wing and the plane, the body of the plane for that specific average. And one other way statistics works in my field is that um, we can determine the probability of an engine having enough power to actually be able to move the airplane and eventually for liftoff.
The probability if that's high.
Yeah, so probability, averages, and there's plenty of other statistics that go into mechanical engineering and all sorts of engineering.
So she was right about those statistics.
Yeah, Professor London says, where there's data, there's statistics.
So what would you say your greatest challenge and or opportunity is as a promising mechanical engineer?
Well, that's a good question because the NAE, a nonprofit organization that promotes engineering, the engineering profession, has reported 14 greatest challenges of the 21st century. And so, mechanical engineering covers, or directly or indirectly, almost all of those, as well as all the other engineering fields. And mechanical engineering specifically focuses on anywhere from thermodynamics to robotics, and so you can tell that mechanical engineering is a pretty broad field.
Right. I think I've actually heard of those challenges. So I'm not sure how I feel about engineers like reverse engineering the brain, but preventing nuclear terror, I think that's definitely a valid use of engineering. How would you go about doing that?
Well, even reverse engineering the brain, we wouldn't have anything to do specifically with the process that a scientist would go into, or a surgeon would go into reverse engineering the brain. Um, but as a mechanical engineer, you can definitely develop tools and methods, more specifically tools that are small enough to diagnose or actually operate on somebody, and the brain itself, because it's such a delicate um, piece of the body. As for nuclear, preventing nuclear tears in the 21st century, it seems like it's something that mechanical engineers really have to focus on. That would have to be developing any sort of machine or prototype or some sort of concept that would intercept a nuclear rocket that would be on the attack. Maybe any kind of sonar that would detect a nuclear warhead that is on its way here or in any land where an engineer would be able to utilize that sort of technology.
Wow, that's a lot. I can't believe how broad yet advanced the field of mechanical engineering is.
Yeah, in fact, all fields of engineering are equally broad, and the more that technology advances, the more those engineering fields will be broad. A scientist explores what is, and an engineer creates what has not been.
We just want to thank you for listening to this video and watching. And I'm Christopher Babb.
I'm Andrew Aziz.
I'm Josh Waite.
Thank you.